Hi everyone, and welcome to this video going over lesson 7.1, parallel lines and angle relationships. Parallel lines are lines that never intersect. They go on forever and ever and ever just next to each other, but never cross one another. So that is what it means for lines to be parallel. And a transversal is a line that intersects two or more lines in different points. So if I had two parallel lines in a line that went through those lines, that would be called a transversal. And what we are going to talk about in this video is if we have two parallel lines and a transversal that goes between them, we create a lot of different angle pairs that have special relationships. So notice how I have lines K and I, and they are parallel. I know that they're parallel because of this symbol right here. If we have an arrow going through two lines, that's talking about how they are parallel. And then notice how I have this line L that cuts through the parallel lines. That is my transversal. And we're going to talk about the angle pairs that are created from this figure. So the first pair is called corresponding angles. Corresponding angles are a pair of angles such that the angles are on the same side of the transversal, and one angle is between the two parallel lines. So I want two angles that are on the same side of the transversal, and one angle is between the parallel lines. So for example, 1 and 5. Notice how 1 and 5 are both on the left side of the transversal, and 5 is in between the parallel lines. This is an example of corresponding angles. I also want you to know that they have the same orientation. Notice how they both point up. That's another indication of corresponding angles. So angles 1 and angle 5. We also have angle 4 and angle 8. Those are on the same side of the transversal, and 4 is in between the parallel lines. And you could go on the opposite side of the transversal. So how about 7 and 3? Those are on the same side of the transversal, and 3 is in between the parallel lines. So angle 7 and angle 3. So those are corresponding angles. Corresponding angles are congruent. So if you see a pair of corresponding angles, you know that they have the same measure. Next, let's talk about same side interior angles. As the name indicates, same side interior angles are both on the same side of the transversal, and they're both inside the parallel lines. So same side interior angles are between the parallel lines and on the same side of the transversal. So for example, angle 5 and angle 4. Those angles are on the same side of the transversal. They're both on the left, and they're both in between the parallel lines. They're in the interior. So angle 5 and angle 4. And we can go on the other side of the transversal as well. And angle 6 and angle 3 are also same side interior angles. So angle 3 and angle 6 are also same side interior angles. And same side interior angles are supplementary. They're supplementary, which means they're going to add up to 180 degrees. And our last angle pair is alternate interior angles. Alternate interior angles, like it sounds, are on opposite sides alternate sides of the transversal, and they're both between the parallel lines. So for example, angle 5 and angle 3, they're on alternate sides of the transversal, and they're also on alternate placements. So notice how 5 is on the bottom while 3 is on the top, and they're both in between the parallel lines. So angles 5 and angle 3, and angle 4 and angle 6. Those are also alternate interior, on alternate sides of the transversal, and in between the parallel lines. And alternate interior angles are congruent. They are congruent. They have the same measure. And so let's practice with a different picture identifying all of these angle pairs. So here are my parallel lines. I can tell by the arrows. And this is my transversal. And I want to identify all of the corresponding angles. Corresponding angles are angles that are on the same side of the transversal, and they have the same orientation. One is going to be outside the parallel lines, and one is going to be inside the parallel lines. So for example, 1 and 7, notice how they both point upwards. We also have angles 8 and 6. Those both point downwards and are on the same side of the transversal. On the other side of the transversal, we have angles 4 and 2. Those both point upwards. And we have angles 3 and 5. 3 is inside the parallel lines, and angle 5 is not. Those are all of my corresponding angles, and remember, corresponding angles are congruent. So all of those angle pairs are congruent. Next, I want to find my same side interior angles. Same side interior angles are angles on the same side of the transversal and both inside the parallel lines. So for example, 7 and 8. They are both in the interior and on the same side of the transversal. And also 4 and 3. And remember, same side interior angles are supplementary. So 7 and 8 will add up to 180, and 4 and 3 will add up to 180. And lastly, I want alternate interior angles. Alternate interior angles are on alternate sides of the transversal, but both inside the parallel lines. So for example, 8 and 4, those are on alternate sides of the transversal, and both inside the parallel lines. And 7 and 3. And remember, alternate interior angles are congruent. So in number 1, it says name an angle that is congruent to angle 1. Well, I know that corresponding angles are congruent and alternate interior angles are congruent. So I want to know what angles are congruent to 1. Well, I know that 1 and 7 will be congruent because they are corresponding angles. So angle 7. I know that angle 3 will be congruent to angle 1 because those are vertical angles. I know that angle 5 will be congruent to angle 1 since it's congruent to angle 7 through vertical angles. And I believe those are all the angles that are congruent with angle 1. Number 2. Shelley claims that angle 5 is congruent to angle 6. Is she correct? So let's find angle 5 and angle 6. Those are right here. Angle 5 and angle 6 form a linear pair. So I know that they're going to add up to 180, but I don't know that they're congruent. They are not vertical angles, they are not alternate interior, and they are not corresponding. All I know is that they're going to add up to 180, but I don't know that they're congruent. So Shelley is wrong. Shelley is wrong. Angle 5 and angle 6 are supplementary because they form a linear pair, but we don't know if they're congruent. So now that we have these angle pairs and we know their relationships, I want to write these out as postulates and theorems. So if two parallel lines are cut by a transversal, then the corresponding angles are congruent. That's the corresponding angles postulate. If two parallel lines are cut by a transversal, then the alternate interior angles are also congruent. That is the alternate interior angles theorem. And lastly, if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. Now, the corresponding angles postulate is a postulate, which means we just accept this one to be true without proof. But the other two are theorems, which means we can prove them. So let's prove the same side interior angles theorem together. So given M and N are parallel lines, and this is the symbol for parallel, we are trying to prove that 4 and 5, which are same side interior angles, are supplementary. So number 1, lines M and N are parallel. This was given to us. Because those lines are parallel, I know that angle 1 is congruent to angle 5 because angle 1 and angle 5 are corresponding angles. And I know that by the corresponding angles postulate. We just wrote that one down. Because those angles are congruent, it means they have the same measure. That's the definition of congruent. If two angles are congruent, they have the same measure. Then I'm told that the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. And this is because if we look at the picture, angle 1 and angle 4 form a linear pair. That's the linear pair postulate. If two angles form a linear pair, then their measures add up to 180 degrees. Now, in statement 3, we said that the measure of angle 1 equals the measure of angle 5. So what I can do is I can plug in the measure of angle 5 in for the measure of angle 1, since those are the same. That's the substitution property. And since angle 5 and angle 4 add up to 180 degrees, that must mean that angles 4 and 5 are supplementary by the definition of supplementary. And there we've proved that same side interior angles are supplementary. Let's try this one more time, but let's prove the alternate interior angles theorem. So same start, given that M and N are parallel, I want to prove that these alternate interior angles 4 and 6 are congruent. So I'm starting with my given, that lines M and N are parallel. Then it says that angle 4 is congruent to angle 2. What's the relationship between angles 4 and 2? Well, they're vertical angles. That's the vertical angles theorem. And then it says that angles 2 and 6 are congruent. And I know that 2 and 6 are congruent because those are corresponding angles. That's the corresponding angles postulate. And if 4 is congruent to angle 2, and angle 2 is congruent to angle 6, this must mean that angle 4 and angle 6 are congruent by the transitive property. Because both angle 4 and angle 6 are congruent to angle 2, they must be congruent to each other. So we proved that alternate interior angles are congruent. We also proved that same side interior angles are supplementary, and we should know that corresponding angles are congruent as well. Please start reviewing those angle pairs and memorizing their relationships, and please let me know if you have any questions. I will see you in class.